Hello students, good morning. You are welcome to Prepclass Talks, and with you is Mr. Chima, your Prepclass tutor on chemistry. So today we'll also be looking at WAEC past question papers on chemistry for the year 2020. Now, in our previous videos, we have looked at questions 1 to 25. We have actually solved and destroyed question 1 to 25. We have shown that chemistry is a very interesting and very simple subject to learn. Do not mind what people are talking about science. It's not actually difficult. And we have been proving that in all our videos. So today we'll continue with question number 26 to 30. We're looking at number 26 to 30 on WAEC chemistry for the year 2020. So students, do not forget to always like our YouTube channel. That is, subscribe and like our YouTube channel. Feel free to always drop your comments or views on our comment section box to let us know what you think about our videos. Try to always share our videos so that some of your peers which will find such an opportunity will not miss out on these very entertaining and educational videos brought to you by Prepclass. So quickly, we are going to be looking at questions 26 to 30 of WAEC 2020 on chemistry. So let us go. Number 26. Which of the following statement is correct for a reaction at equilibrium? Which of the following statement is correct for a reaction at equilibrium? A. All reactions cease to occur. B. The reaction has gone to completion. C. The rates of the forward and backward reactions are equal. And D. The amount of product equals the amount of reactant. Now look at what I did here to simplify everything. Now I said that for a reaction to be at equilibrium, you must understand two very important conditions. One, it must be a reversible reaction. That is number one. It must be a reversible reaction. Number two, both the forward and backward reaction will be taking place at the same time and at the same rate. Did you see what I give you? That one, that for a chemical system to be in equilibrium, one, it must be a reversible reaction. Two, both the forward and backward reaction will be taking place at the same time and they will be occurring at the same rate. Look at the typical example I gave you here. This is esterification reaction. The reaction between an alkanoic acid and an alcohol is known as esterification. It gives rise to ester and water, and as you can see, it is a reversible reaction. Reversible reaction tells you that as the products are combining to form as the reactants are combining to form the product, which is the forward reaction, the product are also combining to give back the reactants. Telling you that it's a reversible reaction and it must be taking place at the same time and at the same rate. So that is why the correct option to this answer is that the rate of the forward and backward reaction are equal. That means that they are occurring at the same time and they are occurring at the same speed or at the same rate. So C is the correct answer. The rate of the forward and backward reactions are equal. Number 27. Which of the following reactions are always exothermic? Which of the following reactions are always exothermic? In terms of heat, we have two types of reaction: endothermic reaction and exothermic reaction. Endothermic reaction is a kind of reaction in which heat is given out to the surrounding. Am I correct? No. I think that is exothermic, brother. Endothermic reaction is a reaction in which heat is actually absorbed from the surroundings. Endothermic reaction is one in which heat is absorbed from the surrounding. But exothermic reaction is the one in which heat is given off to the surrounding. So you must understand the two. Endo, heat is absorbed. Exo, heat is given off. Now they are asking you between these three that which of the following reaction is always exothermic. Which of these three are always exothermic? Visualization, decomposition, and combustion. Now look at what I explained here. Now I said that for the first one, neutralization, When an acid reacts with a base to form salt and water, heat is usually given off, known as the heat of neutralization. Therefore, the reaction is always exothermic. Maybe in your chemistry lab, I don't know, if you can get a test tube, maybe 5 ml in a test tube of dilute acid, then another 5 ml in a test tube of dilute sodium hydroxide. Maybe the first one is dilute HCl, dilute sodium hydroxide. So now just make sure it's dilute, or don't use concentrated forms. So just empty the NaOH into the dilute base, which is NaOH, into the what? Test tube containing dilute acid. Touch the bottom of the test tube, you feel warm. As the reaction is taking place, touch the bottom of the test tube, you feel hot, and the test tube is hot. So because heat is given off, neutralization reaction is an exothermic reaction. Now, for the second one, decomposition. Now, decomposition simply means the tendency of a substance to break and split into two. Now, for a substance or a compound to break and split into two simpler forms, heat in most cases is usually absorbed. So decomposition reaction usually require heat for the reaction to even take place. So because it requires heat for the reaction to take place, it simply means that heat must be absorbed from the surrounding for the reaction to take place. So because of that, decomposition reaction in most cases are endothermic. Now look at the third one, combustion. Combustion simply means burning. Once a substance burns, of course you know that heat and light will be produced. That one is a must. There is no gray area. Once a compound combusts or burns, heat will be produced, light will be produced as fire, and it's hot. So because heat and light are produced, or simply because heat is given off to the surrounding, combustion reactions are always exothermic. So in between these three reactions, the ones that are always exothermic are neutralization reaction and combustion reaction. So the correct answer is 1 and 3 only. 1 and 3 only. B. You see here they've made another mistake. They choose 1, 2, 3. No. The correct answer is 1 and 3 only. 1 and 3 only. Decomposition and neutralization reaction and combustion reaction. Number 28. Which of the following standard conditions is not correct about energy changes? Which of the following standard conditions is not correct? Not correct about energy changes? A. Is it that the standard temperature is 298 Kelvin? B. Is it that the standard temperature is 18 cm? C. Is it that the concentration of solution must be a 1 mole per dm cube? And D. Is it that the heat of reaction will always be at 293 Kelvin is activation energy? Now if you look at this, it's a bit somehow tricky, but it's actually simple. Why? Now let us open them up. For the first option A, that says that the standard temperature is 293 Kelvin. Now what is 293 Kelvin? 293 Kelvin is actually room temperature, which is 25 degrees Celsius. So normally, for normal standard reaction, it usually takes place at 25 degrees Celsius, which is room temperature. So room temperature is a standard temperature, 25 degrees Celsius, which is 293 Kelvin. So that means option A is correct. Option B is telling you if where standard pressure is 1 atm. Yes, standard pressure is 1 atm, which is actually 760 millimeter mercury. So option B is also correct. So remember that I'm looking for the one that is not correct. Option C, the solutions are usually prepared or diluted to 1 mole dm cube. Yes, when we mostly dilute substances, we usually dilute it in 1 liter of water for standard dilution, and 1 liter of water is 1 dm cube. So most substances are usually diluted at 1 dm cube. But the last one now says that the last one is telling you if at normal reaction at room temperature, if at this heat of reaction at room temperature is activation energy. What's activation energy? That's the first thing we have to know. Now, activation energy is the average energy that must be attained before a reaction can occur. So before any chemical reaction can take place, are you following? It must reach the activation energy before any reaction can take place. That is, before reactants can be converted to products, that reaction must attain its activation energy. If it does, a reaction will not take place. So you can't tell me that all reaction will take place at room temperature. No. If I add few drops of dilute Fehling's solution, which is blue, to a solution of glucose, I expect glucose to reduce Fehling's solution to brick red color of copper 1 oxide, and that is a simple test for reducing agent, most especially glucose. If you add few drops of Fehling's solution to glucose, what you get is brick red coloration, which is glucose will reduce Fehling's solution to brick red copper 1 oxide. That kind of reaction will not take place at all until you boil it. So if you just add the Fehling's solution to the glucose solution, nothing will happen. It will just be blue looking at you. Are you following? So it's until you now heat it that the reaction will now take place. Which simply means that before some reaction can attain activation energy, heat must be what? Increased. And that means that, remember that boiling is 100 degrees Celsius. But this place is telling us that activation energy is 293 Kelvin, which is 25 degrees Celsius. No, this kind of reaction I've given you takes place at boiling point, 100 degrees Celsius. So obviously, most reactions do not attain activation energy at room temperature. So because of that, option D is wrong. Are you following? So the correct answer here is option D, that it is not correct, telling us that most reaction takes place or reach activation energy at room temperature is completely wrong. So option D is the answer that is not correct among these two, and according to the question, it is the correct answer to choose. Question number 29. If 5.0 centimeter cube of 0.20 mole dm cube Na2CO3, that's sodium triisocarbonate 4, was diluted to 250 centimeter cube solution, what would be the concentration of the resulting solution? A, is it 0.04? Is it 0.02? Is it 0.2? Is it 0.4? Now there's a formula that says C1V1 is equals to C2V2. If you are diluting a substance and comparing it with another one, it's assumed that 5 centimeter cube of whatever the compound is, 5 centimeter cube of this concentration of the compound, even if you pour 1 bucket of water into that 5 centimeter cube of that compound, it will still contain the same amount of the substance in solution. I don't even understand what I'm trying to say. Now, take for example, I put 1 spoon of sugar in a cup of water. Let's assume that 1 spoon of sugar is 10 grams. I added it to a cup of water and mix. Even if I use 1 bottle of water to pour inside that 1 cup of sugar, the amount of sugar in that solution is still 1 spoon, which is 10 grams. I believe you understand that now. So, no matter the amount of dilution, the amount of water you added to that substance or to that solution to dilute it, it still contains the same amount of the substance. You get? So to solve it simply, you just use C1V1 is equals to C2V2. First concentration times the volume equals second concentration times the volume, because the amount of the substance in both solutions are basically the same. Do you get? So the first concentration C1 is 0.2 mole per dm cube. The first volume V1, you have to convert it this centimeter cube to dm cube, and centimeter cube to dm cube is divided by 1000. So divide 5.0 by 1000, you get 0.005 dm cube. Very simple. C2 is the second concentration. They're asking us the new concentration after adding 250 centimeter cube of water. Do you understand? So now C2 is the new concentration we are looking for. V2 is the volume that you've added, or the volume that it will give us after you've added some quantity of water. They didn't tell us the volume added, because normally the volume added is supposed to be 250 minus 5 centimeter cube. Are you following? So they're asking us the concentration after you've added some quantity of water that have made up this volume of 250 cm cube. So C1V1 equals C2. Convert this one to dm cube. You have 250 divided by 1000, and that will give you 0.25. Applying your formula, first C1V1 equals C2V2. This times this will give us this, equals this times this will give us this. Divide both sides by 0.25, and your concentration C2 is 0.05. mole per dm cube. Very simple, very interesting. So this is now the correct answer. We got what? 0.004 mole dm cube, and that's the correct answer. Option A is the right answer from our calculation. 0.004 mole dm cube. Very simple. Question number 30 and the last for today. It says the initial volume and pressure of a given mass of gas is V and 3P. This is the initial volume V, initial pressure 3P. What is its pressure if its volume is increased to 2V at a constant temperature? Very simple. This is Boyle's law. And Boyle's law says just P1 V1 equals P2 V2. Very simple. First pressure times, because the pressure of the given gas is inversely proportional to its volume. And when you now apply proportionality constant and everything, it gives you P1 V1 equals P2 V2. So P1 is the first initial pressure of 3P, V1 initial volume V. They're asking you the new pressure unknown. V2 is the 2V. So just substitute your values. 3P times V1, which is V, equals P2 times V2. This V2, which is 2V. You get this. Very simple. P1 is 3P, which is 3P, times V1 is V, which is V, equals P2 is unknown. Write our P2 times V2, which is 2V. Very simple. So when you continue that, you get your P2 to be equals to, from here, after you've multiplied and divide both sides by 2V, you now get your P2 to be equals to 3P times V over 2V. So V will cancel V, and we get our P2 to be equals to 3P over 2. Which simply means 3 over 2P, 3 over 2P, which is 3 over 2P. And if you look here, your correct answer is 3 over 2P, C. Very simple, very interesting. Okay, students, I believe you enjoyed this video on today on chemistry questions 25 to 30. If you see here, you are going to see a link to our WhatsApp group. So try as much as possible to join us on this link to our WhatsApp group. And if you do that, you'll be having updates, or you'll be regularly updated on the current video on our YouTube channel that you find very interested in taking part with. So today we have come to the end of this section. I still remain Mr. Chima, your prep class tutor on chemistry, and I'm going to see you next time. Bye.